First, let's review the basic structure of an atom. A subatomic particle are the parts that make up an atom. There are three subatomic particles. The electron, which is symbolized with an E and a negative sign. It has a negative charge. It can change in an element. You can lose electrons and you can gain electrons. And these electrons are found outside of the nucleus. The next subatomic particle is the proton. A proton has a positive charge. These cannot change in the element. For example, if you have carbon, carbon is number 6 on the periodic table, which means it has 6 protons. Every atom of carbon has 6 protons. If you add oxygen, oxygen is number 8 on the periodic table. It has 8 protons. Every single atom of oxygen has 8 protons. So it is essentially the proton that defines what element it is. And these protons are found in the nucleus. A neutron is the last subatomic particle. Neutrons are neutral, meaning that they have no charge to them. These can change in an element, so an atom can gain or lose neutrons and still be the same atom. An oxygen atom could gain or lose neutrons, but it's still an oxygen atom, so they can change. These also are found in the nucleus with the protons. The important thing to remember is that these protons and neutrons add up to the mass of an element. You should know all of these subatomic particles, the charges, which ones can change, and the location within the atom. If we are talking about an atom that is neutral, for every proton, and protons are positive, remember, in order to balance out those positives, I must have an equal number of negatives, and the negative particle is the electron. If the positives are equal to the negatives, then there is no charge on the atom, and it is therefore neutral. When atoms interact with one another in order to form a compound, such as CO2 or H2O, it is the electrons that intermingle with one another. There are several different ways that compounds can form, or the elements can bond to one another, but you'll learn about those in chemistry. Next, we have to learn how to read the periodic table of elements. When you're looking at the periodic table of elements, the number that is above the symbol is going to be called your atomic number. The atomic number is the number of protons. So the order of the elements on the periodic table is according to how many protons they have. Number 1 is hydrogen. It has 1 proton. Now remember from the first slide that every single hydrogen atom must have 1 proton. If the atom does not have 1 proton, it's not hydrogen. Under that atomic number is the symbol for the element. Next comes the name, and then finally an atomic weight. It's a decimal because it's actually an average weight, because not every single atom of carbon has the same mass, because sometimes the neutrons change, and neutrons contribute to the mass. And so the number there is a decimal because it is an average. When we're using the periodic table to figure out the number of protons, neutrons, and electrons, we will round this number if we're looking at a neutral atom and the mass is not given to you. So some key things that you should know. The atomic number tells you the number of protons. If the atom is neutral, it is also the number of electrons because the positives have to equal out the negatives. To calculate atomic weight, it's going to be the protons plus the neutrons added together. So here you can see that carbon has a mass of 12. According to the atomic number, it has 6 protons. So if the mass is 12 and I already have 6 protons, that means that I have 6 neutrons. If I was looking at a neutral atom, that means that the number of protons that I have here is also going to be the number of electrons that I have. Now remember from the first slide that not every atom of an element has the same number of neutrons. They can also change the number of electrons, but, for example, carbon always has 6 protons. That's what makes it a carbon atom. So if we change the mass, we have an isotope. And the change in mass comes from a different number of neutrons. They still have the same number of protons, but the mass has been altered because of a change in neutrons. So a carbon atom can have a mass of 14, a mass of 13, or a mass of 12. The number afterwards tells us the mass. So every single one of these carbon atoms has 6 protons because carbon always has 6 protons. Now your protons plus your neutrons give you your mass. So if I have an isotope of carbon-14, that would mean that I have 6 protons in that carbon, and in order to get a mass up to 14, I must have 8 neutrons in that isotope. If I had carbon-13, I again have 6 protons, but now in order to get a mass of 13, I only have 7 neutrons. And if I had carbon-12, again, 6 protons, and in order to get a mass of 12, 6 neutrons. Now, how many electrons do these guys have? Well, they are neutral still. And since they're neutral, you're going to have the same number of protons as you do electrons to balance out the positive and negative charge. So I still have 6 electrons in every single one of these. So when we write an isotope, we end up being given the mass of the isotope, just like we saw before. Here is carbon-7, here is carbon-8. So there's a change in neutrons. Again, carbon has 6 protons. So if I've got carbon-7, I would have 6 protons, and in order to get to 7, I would have 1 neutron. If I have carbon-8, I would have 2 neutrons. 2 plus 6 gives me my mass of 8. Again, how many electrons do I have? The electrons are equal to my protons because my positive and negative charge equals each other. So I've got 6 protons. That means that I'm going to have 6 electrons in both of these. Another part of the atom that can change is the electron. Electrons are the negatively charged particle. So that means that when an ion forms, we're going to change the charge of the atom. It's no longer going to be neutral. So since it's not neutral, If I were to gain electrons, I'm gaining negative charge. So that means that my overall charge is going to be negative. If I lose electrons, then that means I'm going to have more protons than electrons, so my overall charge is going to be positive. So an ion is a charged atom. These atoms gain or lose electrons. If it's positively charged, that means that it lost electrons and it's called a cation. If it's negatively charged, that means that it gained electrons and it's called an anion. These look a little bit different than the isotopes did. Let's say I have fluorine with a negative charge. This is what we're going to see. Or maybe I have magnesium with a positive 2 charge. This is how it's written. Now, remember that the atom still always has the same number of protons. So if I look on the periodic table, fluorine has 9 protons. Now, if I have to have a negative charge, that means that I need to have one more electron. So that means I've got to have 10 electrons. Now, in order to figure out my neutrons, I'm just going to look at the mass on the periodic table and round it. So the mass on the periodic table for fluorine is 19. So I've already got 9 of that 19 from my protons right here. So now that means that I would need to have 10 neutrons. 9 and 10 gives me my mass of 19. See if you can figure out magnesium. So if you look on the periodic table, magnesium is number 12. That means it has 12 protons. If I look on the periodic table, it says magnesium has a mass of 24. So that means that my protons plus my neutrons have to equal 24. So I've got 12 neutrons. So if I have a positive 2 charge, that means that I have to have 2 more positives than I do negatives. So I must have lost 2 electrons. So I've only got 10 negatives. I've got 2 more positives to give me the plus 2 charge here. All right, time to do some practice. Sodium 24. First thing you should recognize is that this is an isotope. And so our neutrons are going to change. On the second one, we have a neutral atom of sodium. And on the third one, we have a positively charged ion. If I look on the periodic table, I find that sodium is number 11. So right away, for protons, I can put in 11. Every single atom of sodium has 11 protons. Now, the first one, the isotope. Remember that mass is going to be equal to your protons plus your neutrons. When you've got protons plus neutrons, our mass is right here with an isotope, so that means 11 plus my neutrons has to equal 24. So that means I must need 13 neutrons to add up to 24. Now this is a neutral atom, so my positives need to equal my negatives to remain neutral. So I also have 11 electrons. On the next one, sodium atom is neutral. So positives equal negatives. And I look at the periodic table in order to figure out what the mass is. In this case, the mass of sodium says 22.99. I'm going to round that to 23. So 11 plus what number equals 23 to give you your neutrons. That means I've got 12 neutrons. Finally, we have a positively charged sodium ion. That means my positives and negatives are not equal to one another. I have one more positive than I do negatives, so I lost an electron. I'm not given a mass here, so I'm going to go ahead and use the mass on the periodic table of 22.99. I'm going to round that to 23, which means again I have 12 neutrons. Take a minute to try some of these on your own. I will tell you the atomic number of calcium. On the periodic table, this is what calcium looks like. So your atomic number is right here, number 20, and your atomic mass is here, 40. Use that to help you see if you can do these three on your own. Pause the video here. Don't forget to do your neutrons also. Sorry, I missed putting that in. So all of these, the first thing you can do right away is fill in the 20 protons. The middle one here, this one's neutral, so it's also got 20 electrons. My mass adds up to 40. 40 minus 20 is 20. 20 plus 20 is 40. Here I have a mass of 39, so that means I've only got 19 electrons, but I still have to balance my positives and negatives. And then if I have a positive 2 ion, I need to have 2 more positives than negatives. So I only have 18 electrons. In order to figure out my neutrons, I still use my mass down here, so it's 20. Go ahead and try this one on your own. This is what sulfur looks like on the periodic table. Remember, atomic number is at the top, atomic mass is at the bottom. Pause the video and try it on your own. Check your answers to see if you did it correctly.